Alright, this video lesson number 4 is we'll talk about work done. So what is work done? Okay, work done actually is defined by force in Newton, okay, multiplied by the distance moved in the directions of the force in meter. Okay, example, you have this object here, right, on the surface, and there's a force, let's say 5 Newton, push the object to the right, and the object move to the right and stop here. Alright, and the distance moved in the directions must be the same direction of the force. Distance moved is about 5 meters. So what is the work done here? So according to the formula, work done is force 5 Newton multiply the distance moved in the directions of the force 5 meter, which is 25 meter. Okay, so 25 Newton meter. Alright, and this is the example how we can actually use force work done. Now, work done also sometimes can be equal to, under certain scenario, can be equal to the gravitational potential energy gained by the object. Example, let's say we have an object, okay, on the surface, on the ground, and there's a W, okay, weight acting downward, and we know weight equal to mass times gravity. Now when we move the object upward to a certain positions, okay, alright, definitely you need a force which is at least equivalent to the W, the weight of the object. So let's say the force that we use here is just 2 Newton, okay, 2 Newton, and the distance moved here, say in the direction of the force, is 1 meter. So we can say actually in terms of work done, okay, we can calculate, we take force 2 Newton times the 2 Newton multiply 1 meter, you get 2 joules. Okay, so joule is the unit for work done, because work done is another form of energy. Okay, in the same manner, since the object is moving to a new position from the surface of the ground, we know that the object actually has gained gravitational potential energy. Therefore, we can use this formula mgh to find the total numbers of gravitational potential energy gain. Now by right, your calculation should become to 2 joules, because GPE is supposed to be equal to the work done. Okay, another formula that we can use besides mgh, if you convert mg to w, so is wh, the weight of the object times the height from the surface. Okay, and let's look at the work example 5 in your handout. It says that there's this object, okay, this is the slope. This object actually is moved from here to the top. It's 4 meter, and then this is the vertical height, 9 meter. Okay, first they ask you what is the work done to move the box from P to Q. Let's say from P to Q. So work done is the force, okay, which is F, force applied, okay, and is given to you, the force is 12 Newton, okay, so you take 12 Newton, you time the distance moved in the direction of the force, which is 4 meter, in this case is this direction, so 4 meter, so you'll get work done 48 Newton. 48 joules. Then the next question asks you to calculate the potential energy, referring to the GPE gained. Okay, when you calculate GPE, Alright, what you need to do is you have to calculate base of vertical height, meaning this is called vertical height. Okay, vertical height. And let's take a look at this. M is given mass 0.5 kg and times 10, and then times height is 9. So you'll get 50 times 9, 5 times 9 is 45 joules. Now you see the amount of GPE calculated is 45, but the WD is 48 joules. Okay, but theoretically by right, work done is supposed to be equal to GPE. But however, it is not equal because some of the energy lost. Okay, when you push the object up, theoretically the work done should be 48 joules, but you only have 45 joules gain in terms of gravitational potential energy, because the remaining 3 joules lost as due to the frictions between the object and the surface of the slope. It can be lost as a heat or lost as a sound due to friction force. So that should be 3, because 48 plus 3 equal to 45 plus 3 equal to 48. Alright, that's all for this lesson.